I have a great pleasure introducing Jeremiah Grossman. He is a founder and CTO of Whitehat Security, and he published a lot of different articles in the security realm, and he was published in New York Times, Forbes, and Wall Street Journal. Also, he participated in major security conferences such as Black Hat, ISSA, and today I'm glad that he's here. And thank you, sir.
Thank you. Good morning, everybody. Thanks for attending my session. The fact that you guys came to a web security session early in the morning, like 10 a.m., says a lot more about you than it does about me. I'm going to tell you a little bit about my background. So I am the founder and CEO of a company called Whitehat Security. We've been around 13 years, and I'll tell you all about that. But don't let the title fool you. I am an honest-to-goodness hacker. I can break into websites, except that I still do all the time. I find it fun and fascinating. But I got into this space an interesting way. I didn't choose security. Perhaps like many of you, security happened to me. I didn't choose it. So when I got my first computer when I was 16. It was a Commodore 64, and I proceeded to learn Pascal and make screensavers. And that was kind of my first foray into programming, learning BASIC, and running on Windows 3.1 and different things like that. So I grew up in Hawaii, so there's only two things to do there when you're a kid growing up there, right? You go to the beach and then you hack stuff. So you go to the beach when there's waves and you hack stuff when there isn't. So it's a pretty interesting lifestyle. When I was 19, I moved to Southern California. I used to work at a company called Amgen when I was 19. They brought me in there because even by that time, I knew my way around Unix a little bit, mostly BSD-derived operating systems. My job there was to web-enable all their arcane Unix back-end processing systems to bring them into the modern web era. So, because I had been doing web development by then, but I also knew a little bit of Unix, so they brought in the teenager. So my job there was to do disaster recovery, backups, password recovery, and make everything web-enabled. This is a really awesome job. The company was Amgen in Thousand Oaks. Perhaps some of you have recognized the name. Within about 6 months, I'd automated myself down to about 15 minutes of work a week. This was awesome because I got to play a lot of Quake and do my electronics engineering homework. And the systems, pretty much took care of themselves, but I got to be the owner, more or less, of these big multi-million-dollar Solaris systems. So I was running System 5 and all things like that, and running Solaris. So that was a pretty cool job. Summer of '99 rolls around, and I'm doing a lot of web hacking and things. And there was a bunch of news stories that said somebody had found vulnerabilities in Yahoo, Amazon, and eBay, and that these websites are insecure. Now, I found this to be particularly interesting, but not for the reasons that you might expect. I thought it was interesting because I didn't know why it was newsworthy. I thought everybody already knew all these websites were littered with vulnerabilities, because I've been developing web applications for several years, even by that time. What was interesting to me, several weeks later, is that the same companies issued press releases, and they said the vulnerabilities are now fixed and these websites are now secure. And I kind of thought to myself, how did they do that? I really wanted to learn. So again, there's no waves in Southern California, not by Hawaii standards, and the water's cold. So everybody has their hobby. So when I go home, I break stuff. I break software mainly. So I signed up myself, again, this is late summer '99, so I log in to Yahoo and I make myself a new email account and I proceed to try to break into my own account to see if I could. Everybody has hobbies, that's mine. It took me about 15 minutes to break into my own account, and the next hour I spent writing a makeshift advisory to send to Yahoo to say, I won, here's the issue, you might want to fix this stuff, and I went on about my life. That was my victory for the evening. It was a lot of fun. I get back to work the next day, and I find that somebody had responded to my anonymous address and saying, thank you very much for letting us know of the issue. We appreciate you wanting to be anonymous, but let us know if we can send you a t-shirt. This is like the coolest thing ever for me. I'm going to get a t-shirt from Yahoo, right? So, and then I started carrying around this dialogue with these people at Yahoo. I didn't know who they were. And they said, well, let us know if you find any more. So I said, okay, I got nothing else to do. Remember, 15 minutes of work, a lot of Quake, so I hack Yahoo in my spare time. So I sent them about a half dozen more issues, and I started to build a relationship with them. And I come to find out only later that one of the people I was communicating with was one of the two founders of Yahoo, David Philo, who happened to be chief of engineering. So he's worth like $8 billion at the time. So I was like, I better spell check my emails. So that one thing led to another, and the recruiter at Yahoo called me and they said, we want you to come up and interview. You're causing us a whole lot of problems. And so I flew up, but I said, well, you guys should be aware I have no degree. I have no formal background in security. I'm a Unix admin studying to be electronics, and by the way, you're Yahoo with the super brains. And they said, no, it's okay. Come on up and interview. So I flew up to Silicon Valley, the land of purple and yellow. And they interviewed me, and they proceeded to interview me for 8 hours straight, asking me every asinine security question that they could possibly dream up, which is like, how many rounds of crypto does DES do? And the finer points of TCP, and how do you set up a firewall the right way? And I had answers to exactly 0 of their questions. Again, I had no background in security, never even seen a security book before. I would just code this stuff, right? I'm kind of like the developers today. So, apologies. I've been suffering them for a while. So I go home and I figure I completely bombed the interview. I'm sure of it, which no problem. I'll just go back to playing Quake. A couple of weeks later, I got an offer letter in the mail from Yahoo, big yellow piece of paper. Basically, it was triple what I was making at Amgen to go drop out of school and go up to Yahoo and work. And I took it to my guidance counselor at school, and she didn't have a very good answer for me, so I left. I dropped out of school and I left. So I get up to Yahoo, and my business card actually said The Hacker Yahoo. And I started January 10th of 2000 with a very loose job description of hacking everything that Yahoo had, preferably for the bad guys did. So it was a pretty cool job, right? I think I was just turned 22, and I remember because most of my time at Amgen, I couldn't go to the company parties because I wasn't old enough to drink. I can only protect their sales and marketing data. So... So I get to Yahoo, and I'm learning my way around, and it took me 6 months to find my feet. So we suffered the very first major DDoS attack, and the FBI is calling us to learn how to deal with this stuff. It was kind of an interesting environment. So 6 months in, I figure out that I have 600 websites, 17,000 publicly facing web servers. Yahoo at the time scaled with UPS trucks. They just dropped off more servers. That's kind of how it worked. And 120 million active users at the time, which now is kind of meaningless in the grand scheme of things with Facebook at 1.3 billion. But it was a lot of users, and they're in 42 countries. It was a mess. And how do you make sure 120 million users play nice? It's like, all right, I can teach just about anybody how to hack a website one way, one time. It's no big deal. It's one of the things I do all the time everywhere I go. So I've spoken at this time 6 continents and 30 countries. But when you're defending against the bad guy, comprehensiveness matters. You have to find all vulnerabilities at all times because they just have to be right once. So you need a methodology. So I developed my methodology because by that time I read every book on web security that I could find. And actually there were no books on web security at the time because web security wasn't even a term then. So the first book my boss gave me was Applied Cryptography. I learned later he was like playing a joke on me, but I learned a lot about cryptography in the process after getting halfway through it. So 40 man-hours was my assessment methodology in average, and you multiply that by 600 websites, and I figure out very quickly that I have 11 and a half years of work ahead of me. So 1, great for job security. 2, we're going to get hacked, and I'm the web security guy. That sucks. So I talked to every expert, tried every product, and nobody had anything that worked. Nothing would scale. So I left. I figured that web security was this really, really big problem. There was kind of this big thing called the web out there. Most websites riddled with vulnerabilities. Nobody had anything that scaled. So I left Yahoo with the idea to start White Hat Security to figure out how to solve this problem because I figured I can do better. So October of 2001, I started White Hat Security. It was just a very modest security consultancy way back then. I was 24, and I got to travel the world breaking websites. I got to work for a Bank of Bermuda. I traveled to Bermuda to hack their banks. I got to go to Japan. This is an awesome, awesome job. And then one thing you learn as a consultant really quick is this. I know if you guys are consultants in the room, I know your job. It's really, really hard. Feast or famine. It's very, very difficult. So doing this all the time, but what I really wanted to do is I wanted to write technology, something that would automatically test all these websites and something that would scale out. So at one point in time, at the end of 2003, we decided to end of life all consulting and convert to what was later became known as a software as a service model, to put all our scanning technology on a bunch of servers, test our clients' websites remotely, and add all the results. And augment the results with human analysis. And so today, 13 years later, we have the world's largest web hacker army, 125 people whose all day long is hack websites. It's the coolest thing you have ever seen to have the get out of jail free card to hack 600 banks today. We're doing more assessments than anybody else out there, and the way we do it is really, really different. Now, I'm telling you all this not so much about the company, but because it tells you the challenges of web security. One of the things you figure out in web security, you work in it long enough, you're going to come to one very long-lasting conclusion, that there's nothing in web and software security that can be fully automated away. There's not a single thing, not threat modeling, not vulnerability assessment, not training, not source code reviews, zero. There is nothing that can be fully automated away. You come to the conclusion that everything's going to take, every solution, if it's going to be called a solution, people, process, and tech. So if you're going to build the tech, it has to be designed as a people force multiplier. How do you make efficient use of your experts? Now, the number one challenge in all of web software security, even Richard Clark made mention of it, the number one challenge we have in web security and software security and also information security is we simply don't have enough competent, skilled people. They're just not here, and the cavalry is not coming. Go look at those that are going into computer science. It's flat or down. We're going to have to indoctrinate more people from outside the industry to help. So here's how it works. If you're going to start solving web security for your customers, or you are the customer, you have to look in the ecosystem and who's in the best position to hire, train, and retain the best application security talent on the planet. That's the only way it works. And the second thing is there is power in numbers. There are no web security experts as far as I can tell anymore because the problem space is too big. When we go after and test websites now, we do it as small armies. Because what we find in our hacker games that we play at the office, we call it hacker combat. If you take 2 or 3 of our best guys and you put them against, let's say, 6 to 10 guys that have no more than a year of experience, the bigger team will always win. If you go to DEF CON Capture the Flag, if you do any Capture the Flag contest, you look real close, the biggest team always wins. There is power in numbers because everybody will complement everybody else. Now, the data we collect here, and this is kind of what we're all about here, the data we collect here is going to come from 30,000 websites, 650 active customers, and all over the place. We actually, we have the get out of jail free card to test all these websites. So from this data, from this real world data, we get to make slices of it and learn things, and the things that we learn, we share back out freely with the community. But the way we operate internally is that software and web security is really, really important. It's really important to us. Now, there's not a single person in this room, and I would wager to guess there's not a single person that you know that is not going to use the web today and is not going to use some form of software today. You probably couldn't have got here today without the reliance on some form of software. It's in our phones, it's in our computers, it's in our pacemakers, it's, power grids. Software is really important. It has, let's just say the word, infected every part of modern everyday life. Now, something this important must be secured. So those who are in the positions to do something about it, white hat, we see it as a responsibility, it's a privilege, really, to be trusted to do these things. So here's what I'm going to discuss today. I'm going to go over we're going to focus our area on the topic at hand, which is going after measuring the difference between programming languages and their relative security to each other. That's the title of the talk, right? Now, if you can easily start a holy war in developer land if you say Java is more secure than .NET, is more secure than Perl, PHP, Ruby. It's the greatest way to troll any mailing list online. Give it a shot. Now, the inevitable conclusion of a mailing list war in this regard is every programming language can be made secure or not secure. It really comes down to the developer and what it is that they do. They are technically right, but I'll say practically wrong, because all we care about at the end of the day is outcomes. How these web security languages perform in the real world. .NET versus Java or anything else. I guess Java is Oracle, right? So we're going to go over some key findings. We're going to do some average vulnerabilities of these languages, median days open, because it's not just about numbers of vulnerabilities in these websites by languages, it's how long these vulnerabilities stay open. We're going to go over vulnerability by class or language, industry analysis, who's using what tech, and some recommendations and takeaways. Anyway, so let's see here. When we talk about web security and software security, it's not, for years for years in our sales decks at White Hat, the industry is maturing, but for years at White Hat, we had this one particular slide, I remember it well. We had to personally put in a slide that said, firewalls don't protect websites. Network firewall, we actually we've taken that out over the last couple of years because everybody's figured that part out, that all a firewall does is you put up a firewall, deny all, allow 80 and 443, then all the browsers get in. If you ask every web hacker, they've never seen a firewall. They don't feasibly exist. Those don't really work. Now, while websites and web software have had vulnerabilities for a long, long time, they weren't always the source of breach. Over the last 5 years, web and web-related software has become the #1 vector of compromise, the #1 reason for data loss. So while the world spends all their money on firewalls and antivirus, it's really software that's the problem. As it's been said, network firewalls were a response to an inherently software security problem. I'm here to say that we need more software security, not more security software. So that's what I'm going to try to impart upon you. But second is that if you just go by the data, how many of you have heard of the Verizon data breach report? Excellent. Read it. It's required reading for those that didn't put your hands up in the air. It's required reading. You read this and any report before, it'll tell you one thing. Web software is where the breaches happen. Here's the narrative. If you're an enterprise, somebody over a certain size of business, bad guy will find a secondary or tertiary website, probably one that you didn't know existed. They'll hit you a SQL injection or some kind of injection attack that gets command level access on the system. They'll use that access to root the box and implant customized malware, customized to beat the AV. They'll then pivot across the network to something that you do care about, where the data exists. Then they'll start exfiltrating data, and that process will take a few days to weeks or months or never for you to notice. That's pretty much how it works. If you're small to medium enterprise business, they're going to get you through your remote desktop misconfigs area because usually that's the easiest path. So just bear that in mind. So web applications, when we talk about this stuff, is how the breaches happen despite all the money being spent on network security controls that don't work. So now the other one that I find fascinating, and it's only tangentially related to this one, is I like to look at who's spending what money on insurance. And so I look at very, very closely at the insurance industry and seeing what types of insurance they offer, what the premiums are, and what the payouts are. And there have been payouts as high as $20 million with average payouts at around $900,000. So actually, if you look at the cyber insurance industry, it's big, complex, and nuanced at this point. It's amazing. So we know the breaches are happening, but it's almost like the insurance companies don't care about the how at this point. They're making a lot of money anyway because businesses are really scared that they're going to get hacked. And they're right. So what are the big questions? Are some programming languages more secure than others? I'm going to say yes, but in different ways. What are the prevalent threats per programming language? And what are the prevalent threats by industry? So let's talk about the data. 30,000 websites in all. We know that. This is all data from Sentinel stuff at White Hat, so we've been doing this a long, long time. And we're focused on the programming language itself. I'll get you all the list. So let's go over some of the key findings here real quickly. We did this research 2 years ago, and we're redoing it now. But one of the interesting things is people said, well, clearly .NET is more secure than ASP Classic. And what we found at that time was that they were technically correct, but only if you chose the metric was vulnerability volume. So what we found at that particular time was that if you notice classic sites versus .NET, the classic sites had about 20% more vulnerabilities than our .NET compatriots. However, what's interesting about the new .NET frameworks, and as we know, that a lot of these new frameworks are very forgiving security-wise in the developer. You have to work really hard to be vulnerable to SQL injection. You have to work very hard to be vulnerable to cross-site request forgery, cross-site scripting, and all the other esoteric names that we have in this industry. But what happens is when you find a vulnerability in .NET and a .NET-related website, because the frameworks are so forgiving, developers never had to learn how to defend against cross-site scripting or SQL injection. So when they happen, they have to learn how to fix it, which extends their time to fix. In the Perl classic areas, they've never had anything to help them, so they had to know how to fix cross-site scripting and SQL injection. So their vulnerability numbers are higher, but the time to fix is shortening. So how do we go about finding out which languages are on the servers in question? Well, we did a whole lot of analysis, developed some algorithms, some based on headers, some based on URL file extensions, behavior of the site, and we're able to calculate what percentage of the websites we're looking at are using what technology. So these are broad totals. So about 28% or so of the sites that we see have .NET. 25% or so are Java-based. We've still got a whole lot, about 18% or so are ASP Classic-based, and so on down the range. And still, look, we still got the Perl over there, Perl guys hanging out over there. So the web is a very big and complex place. One thing we also notice is that very few websites are technology pure. Now, if you've been in web security a while, you know that websites are built and then rebuilt, but they're never really decommissioned. There's just more on top. So if you look at a lot of these websites, it's actually a collection of technologies in place. So we have to bear that in mind. Any questions so far? I'm going to start getting more data, but yes, sir.
Are you going to address framework differences? So, like, for example, in .NET, that can be written in C# or Visual Basic. We're talking Ruby, whether you're running Rails or you're running something else, those types of things?
Yes, great question. We can't readily distinguish at all, or at least with enough data, on the differences between the .NET and the programming languages. We just know it's using .NET, or even the different versions of Rails, like this, the minor major version numbers. It's just .NET. So there is that variation there, which could skew the data. It could skew it. I'm not so sure that it would, and you'll see by the data I present on why it may or may not. Great question. Yes, sir.
Curious on web application firewall. You're going to be testing on that security software itself. What have you seen?
Sure. I can handle that one right now. It was the subject of our last stats report on which security controls matter. White Hat has great outcome data, but we didn't already know what our customers did behind the scenes to achieve their outcomes, good, bad, or otherwise. Real quickly, I can tell you that I do not think that there's anything that we can classify as a best practice in web security. Every technology or every process can work, or it can be made not to work. The smoking gun we found in our last report is the incentives programs that you put in place at the organization. So to quickly answer your question, it would be if the developers are rewarded for creating secure code or penalized when they don't, they will generate secure code and they will get something out of training. If it's just something that's checkbox required at the organization and you must go through training, it won't work. So in the case of web application firewalls, we have great cases at our customers where they do work and other cases where they won't work. What we find is that when something works or doesn't work, it has everything to do with the accountability in the organization and which group is responsible. So when you test a web application firewall, which one you choose, make sure it can technically work, but make sure the person or the group responsible for them is accountable for its success, and you'll get a good outcome. Does that help? Yeah.
The technical evaluation of you seeing.
Oh, between them? No, if there's going to be a difference, it's going to be very slight technologically and everything to do with the implementation of the config by the group. As far as what they're capable of, it really won't matter to you. Yeah?
For purposes of the metrics, do you differentiate between websites that users log into versus, say, a web services API?
These are all websites, not web services. Everything will work in a browser, not web services. All right, so the mean number of vulnerabilities in each language. So if you looked at a website and it used .NET, the average number of vulnerabilities we saw over a year period of time was 11. So 11 discrete ways to hack a website. These are rated level severity of 3 and higher. To put in more basic terms, these are the ones you should fix, and if you don't fix them, you're not PCI compliant. You'll get a nasty letter from your FFIEC auditor and so on and so forth. So the way we count vulnerabilities is a little different, but it doesn't matter because we're only meant to look at the relative distance between the frameworks. So if you look at the distance between Java and .NET, it's basically the same. But if you also look at the distance between .NET, Java, and ASP Classic, there isn't one. We can't tell a difference between these for whatever the reason. We'll debate the textbooks and the mailing list trolling all we want. All White Hat is saying is that we start measuring these websites using these frameworks, and this is the result. Beyond all the theoretical stuff, that's what happens. So we found no major discernible difference between these languages. We were hopeful that the .NET guys would be down in the 1 to 3 range, but no, actually, nobody was. Everybody has vulnerabilities independent of the language. Questions here? Yes?
How do CDNs affect it? A lot of websites rely on Akamai or other.
Sure. So content delivery networks, ones that meant to speed up the website, very little, if not at all. So depending on the customer, sometimes we have to mostly stay on domain, meaning bank.com, if it goes to, bank.akamai.com or something like that. Sometimes we'll add it in, and sometimes we won't, but a lot of times those guys are just serving static content, which won't add or remove from the security of it too much. But for the most part, I would say with this data, it would be a non-finding. It wouldn't take those guys into account because we mostly have to stay on domain. Any other questions? Okay. So some of the risk exposure here. Let's see here. Risk exposure in languages does not vary widely between languages, as language of choice does not really affect the number of vulnerabilities. Fine. We're going to take a look at risk exposure because there's other metrics that matter more. Time to fix and remediation rate. When we find, how long does it take to fix if it's fixed? So let's look at some of the averages here. We looked at these, so what does this mean? Okay. Let's see, what does this mean? I don't want to go over this one. I like this one better. So cross-site scripting, one of the number one, what is it, Jim? Is this still on OS top 10, the number one? Cross-site scripting, is that SQL injection? Keep forgetting.
Injection's number 1, but XSS is in the top.
Okay, this is on the OS top 10 list. It might be number 4 when they do the risk stuff. But by pure number of vulnerabilities, cross-site scripting is by far the most common issue out there. It's the one the bad guys use when they want to target an account. They'll create a nice little link for you and they'll message it to you over email. You click and you get owned, whether it's on Facebook, LinkedIn, or whatever. So, median days open by language. So when we find cross-site scripting open in a Perl website, the median days open for these vulnerabilities is 184 days. Let's put this in context here. Now, we don't know exactly when that vulnerability went into that website. We can't tell because we get in late to the party, right? But when we find a vulnerability, we say, Mr. Customer, we found this vulnerability in this unique URL. This is how we exploited it. This is how you fix it. This is how you replicate it. Everything you need to know to understand and fix the issue. It is then their responsibility to fix the issue through code fixes, configuration changes, dropping the website, web application firewall, or whatever. And then once they fixed it, our job is to retest it. And we're retesting every single day. So maybe about a week, give or take, is probably the variation there. So their responsibility is to fix. Still, the median number of days, what is that, 6 months in Perl? ASP is 135 days, .NET is 126 days. So we're not talking hours or days to fix these things here on average. We're talking weeks, if not months. And for whatever the reason, I don't really know, but the PHP guys take the number 1 spot. They're able to fix their cross-site scripting vulnerabilities in just under 2 months, so 49 days. When I look at all the data, remediation, from a tactical level, remediation of these web vulnerabilities is actually one of the major problems affecting web security. We can find these all day long, but customers and companies are very stressed to fix these for a variety of reasons. Lack of resources, lack of know-how, lack of time. Maybe the developers who wrote the site have left. Maybe there's no one supporting the site at all, but there's all different sorts of reasons why these issues get fixed slowly, if not ever. So let's look at SQL injection. Everybody here like SQL injection? This is a fun one, right? Or 1 = 1? All right. PHP stood out from the pack with the lowest median of days at 6.8 days. So what does that mean? That means when we find a SQL injection vulnerability in a PHP application, it takes our customers generally just under a week to fix the issue. That's kind of cool. Median number of days by language. In Cold Fusion, it can take, it's open for about 107 days, and so on down the range. So, kind of gives you an idea there. For whatever the reason, .NET is at 2 months, Java is at 2 months, but the PHP guys are there. So it's kind of interesting to look at. PHP has a little bit less vulnerabilities, and they fix SQL injection really fast. Perl, still a little under a month. Is anything striking about this? We found huge variations here on the averages. All right, let's round out the top 5. ASP vulnerabilities overall average number of serious vulnerability in ASP web applications was 139 days. Cold Fusion had the largest days open at 107 days. And languages with the most security controls are taking the longest to remediate. Why? Did you get that? That's really odd, right? We really want security controls in our frameworks, don't we? But when that happens, the remediation length takes a long, long time. It seems to us that developers and companies, development groups, have an over-reliance on security controls. And when they do, this is the consequence. So we're getting what we asked for. All right, let's look at some vulnerability classes. I know this is a bit of an eye chart. I apologize. How many? I'll try to read it across the top. So the first column, these are by classes on the vertical and languages on the horizontal. ASP, Cold Fusion, .NET, Java, and Perl and PHP on the very end. So what this means is that let's just say in the top left corner, that is cross-site scripting on ASP Classic sites. We find one vulnerability in 49% of the websites we look at least one. 46% of Cold Fusion websites have at least one cross-site scripting, and so on down the range. What I found was an interesting mental exercise. If you take columns 1 and 3, ASP Classic and .NET, and run down the range, what you expect to find is a lower percentage in the .NET column. But if you go down the range, you actually don't see that. It's very, very slight. So for instance, information leakage, 29% in Classic and 44% in .NET. The .NET side have more information leaks than the ASP Classic guys, for whatever the reason. SQL injection, it's about the same. So it's kind of interesting to see how far we've come in web and software security as a result of these frameworks. It's not as good as we might like to see. Yes? Any questions? One of the interesting ones we omitted in this report and also this presentation is we're looking at about 120 Ruby on Rails websites right now. We have yet to find one that had a SQL injection vulnerability. Something's working there.
Active record API, what over-parameterized. It's really hard to do SQL injection on real Rails.
So maybe we don't know how to attack the thing yet. Maybe next year we'll figure it out and all the numbers will spike. I don't know, it's new. I don't know. All right, let's talk remediation rates. Sorry, the eye chart again. On the vertical is the class. On the horizontal is the frameworks. These are remediation rates. So again, we found the vulnerability. We have verified that it is actually there. It's not just scanner stuff. And then we've reported it. What percentage of them are actually getting fixed in a 365-day period? So that means on the top left corner of cross-site scripting, ASP Classics, 79% of the ASP vulnerabilities, 79% of the cross-site scripting vulnerabilities in ASP sites are getting fixed. 76% in .NET. Now again, do the same mental exercise. Let's try, if you go same mental exercise, you go down the first and third columns, and you'll see not much variation between the remediation rates until you get way down to the bottom. It's very interesting to look at. And for whatever the reason, if you go down into the Perl one at the very bottom, session fixation on Perl, we've never seen somebody fix a session fixation bug yet. But on the Cold Fusion one, it's kind of interesting. Cold Fusion, when we find abusive functionality issues, those sites fix every single one of them. So there's a few 100%ers in there, which we found interesting, a few 0%ers also. But it just goes to show you that there is variance in the chart, meaning certain languages have trouble fixing certain classes better than others. So not all languages are created equal. When we see their performance in the real world, it is all over the map. So you can actually see where they're good and weak from a real world standpoint. Questions so far? No questions? Okay. So, industry analysis. We want to know who's using what frameworks by industry vertical. So let's see here. In the banking industry, so how many here guys are in the financial services, financial banking? Just a few guys? Other people are reading? Okay, good. When we look at, let's say, remember I said a lot of websites are multiple frameworks? That's why if you look at this chart, it'll add more than 100%. So about 18% of the banking websites are running Classic, and 18% or so are running Cold Fusion. The two biggest ones in banking are going to be .NET and Java. They like their .NET and Java, but we still have some financial services banking customers that are running Perl and PHP. Now, let's look at the cross-site scripting vulnerabilities in these categories. So what this means is that 49% of those websites have at least one cross-site scripting vulnerability. 44% of the .NET websites have at least one info leakage, and 57% of the Java websites in banking have at least one cross-site scripting vulnerability. Just kind of interesting. When we look at this data, we're trying to figure out what this stuff really means. Maybe it means nothing. Maybe these are non-findings, but it is interesting to look at. How about IT? How many here are on IT websites? Ones that help businesses, Okay, cool. All right, so these are more all over the map. A nice cross-section of different technologies in the IT field. There's good Java, 35%, .NET, 35% or so, some ASP Classic, some Cold Fusion, Perl, and PHP. You kind of get the idea here that there's cross-site scripting vulnerabilities still everywhere, independent of the industry, independent of the language of choice. How about retail? Retailers? No retailers? No one's taking credit cards? Come on. So retailers, they like .NET, they like Java, still a lot of ASP Classics, some Cold Fusion, about 15%, not so much Perl anymore, about 5 to 7%, and a little bit of PHP at about 25%. Still cross-site scripting and info leaks in the retail sector by language. Financial services, not quite a bank. We'll go through these real quickly, because I'm running short on time. Healthcare, good cross-section here. .NET, Java, Perl, PHP. Everybody's using a lot of different languages and frameworks.
So basically the same percentage?
Yep, it's pretty much even. So when it really comes down to a little bit of variation on numbers of vulnerability totals, not as much as we like, but a lot of variation on time to fix and remediation rates between the frameworks. Now, if you're looking to protect your business, what's going to matter more to you? The vulnerability volumes or the speed and comprehensiveness of your fixes? Exactly. That's where it's going to come down to. So when you look at your programs, when you start measuring your programs in terms of metrics, if you want to have data guide your language selection, which normally it doesn't really, because that's an after-the-fact kind of thing, but you can start looking at it from this point of view, that if you take our data and say, what languages are we running, and start focusing on those areas where the remediation rates and time to fixes are low. So what are some of some of the lessons learned here? Language of choice, for my part, doesn't really matter all that much from a security perspective. It might matter for hiring of developers, more cheaply or faster time to code release. You want to test, and all through the software development lifecycle. And this is for several reasons. The first one is, first and foremost, is that you want to test through the software development lifecycle, because what you really don't want is something in test or software development, pre-production staging to make its way into production, because then it represents a real risk. I do not subscribe to the concept that fixing vulnerabilities earlier is cheaper. Not so much I disagree with the statement, is I don't think it matters all that much. Let's see what it is. Let's try this, because I have a few minutes here, and I like this concept. You'll hear all the time, right? Fixing vulnerabilities early in the software development lifecycle is cheaper. Right, you guys heard this one? Why do they say that? Because mostly it's borrowed over from fixing bugs is cheaper in development, 10, 100 times cheaper. That's all fine and good. Now, here's the thing. Let's do the math. We're finding 11 vulnerabilities at the highest in these websites, right? So let's just say, let's say 10 to round it out. We'll just go a little bit more even numbers here. Now, maybe I'll pick on Jim. Can I pick on you, Jim? Okay. What is when you find a vulnerability, let's say SQL injection, how much developer time does it say to understand, fix, QA, and push the code for any one particular vulnerability? You can be right, wrong. I know it can, but rough average. No, time. Yeah. For a developer to understand, isolate the flaw, code the fix, QA it, push it, about how much time, developer man hours.
For SQL injection?
Sure.
Very, very little.
8 hours, 10 hours?
Let's even say
Yeah. An hour? Okay. So let's go a full day. You have to take a developer off the ranks for a full day, you know, for QA. Okay. Widest volume. Developer hour, $100 an hour? Okay. That $800 per vulnerability? $800 per vulnerability times 10 vulnerabilities. So $8,000. So it takes $8,000 to fix all these vulnerabilities. So at best, if you do all these things early in the software development lifecycle to make sure those 10 vulnerabilities don't exist, it's probably going to cost you more than $8,000 to actually do all the testing earlier. That part doesn't matter. You're only going to save $8,000, but what you will save the organization is the cost of exploitation, which is way, way higher. Remember the insurance one? Right? What you're trying to stop is not so much get to cheaper vulnerabilities or less vulnerabilities you have to fix. You want to make sure a breach doesn't happen.
That's a totally fair counter-argument to that. And those stats, by the way, are from the 80s. No study since then, and they're often misquoted. So I think that's a fair counter-argument.
So for me, yes, it is cheaper. I'm just saying it doesn't matter. Yes, sir.
Well, the problem is that who cares about the individual SQL injection bug? Fix the freaking framework and fix the code that your developers are using as a whole. Like, if instead of solving for SQL injection in this one page, like, don't let your developers write code that allows that crap to happen. Like, how do we have that? Make sure that that conversation is happening.
You're absolutely right, and I can only say there's actually two conversations happening. Let's say we did that. We can actually make the code that we're writing from today on much more secure. And we should definitely do that. But then the other one happens to be that there's already 975 million websites on the web. And what do we do about all that legacy crap going backwards in time? That one's a really tough one. Because we're still using Perl, PHP, and maybe PHP is okay, but ASP Classic. Those are just reminiscent. Those aren't even being supported most of the time. They're just kind of maintenance. And we're not rebuilding new websites, so we kind of have this dichotomy there, but you're absolutely right. How do I still like making the jobs of developers easier, but it does have a countervailing side effect on remediation rates and time to fix it. So that might have to do with software development processes more than anything else. Yes, sir.
How do you improve the testing methodologies you have all these kind of websites and different things? What, in your experience, has been a way to improve the testing methodology, make it more efficient, more comprehensive?
Sure. So the question is, how do we improve our testing methodologies? Every organization is going to have it different. Every organization has it benefited others. I can tell you how we do it. At White Hat, we have about 54 developers. We write a lot of code ourselves. So one of the things that we did is we're now pushing code weekly, so agile if you want to call it that. So we literally push code weekly. And to make sure we're efficient and speedy, we changed our definition of done. So done for a developer, their job is to take something off the bug track or whatever. And done is when it's actually production ready and it meets all the production standards, not just throwing it over the wall to QA. Right? So what happens is that developers really wanted their testing automated and really, really good because they wanted to test their code to make sure it makes the acceptance testing. So you're going to want to automate as much of your QA process as you possibly can. Right now, at White Hat, we're about 80 to 88% in QA automation. There's certain tests that we have to be done manually. But if you can get your testing, your unit tests, really, really fast, even get your unit tests built before code is laid, that is way, way better. And then you have a efficient and speedy process. When you actually drive towards weekly releases, you find inefficiencies and lack of trust in the system. You weed those out, and you're just flying. That's where you need to be.
Do you find that the automation efficiency changes based on what platform or application the code is written in?
That could be. We're only using one, so I couldn't tell you with any kind of metrics. I'd imagine automation efficiency can probably be heavily dependent on the framework, software stack of choice. I don't have personal experience in that one. Yes, sir. We have developers at a security conference? Kudos to you guys.
Well, but my question was, I used to work for a company, I won't name it, but I took the time to actually learn the APIs and use them in a more secure fashion. I'm not saying I was 100% secure. My coworker didn't. He was just writing code and he was inventing his own little classes and libraries to do stuff. And this was in .NET. So let's say that .NET has frameworks that are secure, that provide security to answer this gentleman's question. But not everybody takes the time to learn because there's 50,000 classes out there. Who can master all 50,000?
Yeah.
Now, in HP Classic, there weren't 50,000 classes. There were 5 or 100,000. So newer languages become more complex. They offer the functionality. And now, just back to your last bullet, you have to train the developers how to use them, and that writing secure code is important.
Yep. So that is true, but I think we have to get to a point where developers are rewarded somehow, shape, or form for developing secure code and penalized when they don't. Every company is going to have a little bit different approach in how they do positive incentive programs for the developers. Once you get that program in place, then they'll want to get something out of training. Yes, sir?
So I want to challenge you to something because you just brought it up. I challenge you to take your definition of done from being through QA to all the way into production.
That's actually, that's what it is. So that's how it was before, and all we did was get crappy code landed at QA, and we had to refactor again and again and again. Once we changed done to it must pass production readiness, then it's done, and it was huge. Was there another question back there somewhere? Oh, yeah. Oh, yes.
Do you ever give any thought to open source? So let's say I'm writing something in Java, I yank down an open source library, it's version 1.0, the public library has a vulnerability that is known by everyone. It gets baked into my software product, which leads to a vulnerability.
Yeah.
It becomes more of a patch issue, like you think of in a traditional patch and fix, but it gets tightly wound. Do you differentiate between mistakes that developers make or where they're pulling in some code that another developer has made out in the open source?
I think that question speaks to the software supply chain, whether the code comes independently sourced, purchased from an outsider, or borrowed from open source. That's a really complex question, and it's not easy on that one. So whose responsibility is to test it, whose responsibility is to fix it or check it, but either way, you have huge software complexity. So I can't answer that question directly because I simply don't know the answer, but what we do know is that our tests are rather generic across the websites, and so we're testing SQL injection generically despite the frameworks, and what happens is that we regularly find O days, we just don't know it. And when we disclose it to our customer, they try to go fix it and they go, whoa, that's not our code, that's somebody else's. And they go, whoa, and the vendor goes, whoa, that's an O day. And we go, oh, sorry, didn't know. But so yes, that happens, but that ecosystem problem is thorny. Don't have a great answer for you there. Yes?
Comment to that, if you're using open source code, it's open source, contribute back. If that's the problem, contribute back to fix.
All right, I'm gonna flip through these. I think I'm out of time here, so anyway. If you have questions, if you want the full report, that's how you get it. If you want to email me and ask questions, that's how you contact me. Is there time for another question, or are we good? Before I end here, do you have any other questions I might be able to answer? Fantastic. Thank you all for having me. Thank you for being here. I'll be around.